In this problem, we are given a polar equation r equals to a times 1 plus cosine theta. A here is a constant. We need to transform it to its equivalent Cartesian form. Let us begin. Now, let's say we have a point P with coordinate x, comma, y. Then if we want to represent this particular coordinate, the x coordinate and the y coordinate in terms of r and theta, then x is going to be given by r cosine theta and y is going to be given by r times sine theta. Now, coming to our problem, we have here r equals to a multiplied to 1 plus cosine theta. Now that means we have to convert it to a Cartesian equation. For that, we have to replace r such that it becomes, we replace it with its equivalent form of x and y, and we also have to replace cosine theta at its equivalent form. Now here we have already mentioned that x is represented by r cosine theta. The cosine theta can be also represented as the ratio x over r. So let's use this. So we get r equals to a times 1 plus x over r. Fine. Let's multiply throughout with r. So we get r squared equals to a multiplied to r plus x. Now we have the polar equation converted to a form which contains r as well as x. Now, how do we replace the value of r? So using the equation x equals to r cos theta and y equals to r cos theta, if we take the square of x and add it to the square of y, then this is going to be equals to r squared times cosine squared theta plus sine squared theta. Now cosine squared theta plus sine squared theta, that's a standard identity with a value equals to 1. So x squared plus y squared will be equals to r squared. Or we can say r is equivalent to square root of x squared plus y squared. Let's replace this value. In place of r squared, we have x squared plus y squared. This will be equals to a times, now in place of r, we'll replace with square root of x squared plus y squared plus x. So this is going to be the Cartesian equation, and in this Cartesian equation, we don't have any r or theta terms. We only have the x and y terms.